This is week 16, and we're going to continue with our third, third last lecture slide that we need to cover for soil science and analysis subject. So today we're going to cover topics regarding soil and environmental pollution, part one. There is a second part also with a similar name, but part two. In the second part, we're going to talk more about how to manage solid waste. It's part of, we probably have learned something similar from solid waste, but we're going to learn it, but with regard specifically on how we can best manage the soil, not solid waste. Yeah. So you can say that this is the major components that we're going to cover today. First of all, definition and concept of soil pollution. What is behavior of organic and inorganic pollutants in soil? So in the second part is where we're going to cover a lot of chemistry, beginning with organic chemistry and followed by inorganic chemistry. So bear with me, yeah? If you're having trouble, do switch on your microphone and stop me. If you do not understand halfway of what I'm talking about, it's very important that you know, yeah? Because those are the questions that come out in your test, yeah? So you better be aware of what I'm saying. And then finally, the fate of all of agricultural waste in soil. Now, this is unavoidable because Malaysia is one of the producers of biomass. So I think you should know where that biomass comes from. It's from oil palm industry lah. So the fate is actually describing how these the migration and then the appearance, what happened to these solid waste in the soil over time. Yeah. So those are the things. Now, a recap of the entire flowchart of soil degradation. We are at the chemical part, okay, the chemical degradation of the soil, in which we are going to cover more on the pollution that is caused by human activities. Now, as you know, there are plenty of compounds or chemicals that may cause this pollution. So it is divided as you can see right there. It could be xenobiotics. Xenobiotics could be a lot of things, but usually these are the compounds that are produced by human. So it could be most likely organic pollutants, and by saying organic pollutants, it could be as small as pesticide, and it could be some very common small molecules like solvent molecules like methane, chloroform. Those are the xenobiotics. Xenobiotics can be as small as that. It could be as big as polymer, your plastic. Plastic also counts under xenobiotics, yeah? And I would say it comes under organic contaminants, yeah? Now, apart from these organic contaminants, it could be also coming from the inorganic side. So when I say inorganic, it counts. It can be this. It can be broken down into two more sections, like heavy metals. Now, I wouldn't say these are heavy metals because by definition it should be heavy and not metals. Toxic wise, they are heavy. So I would rather call this as toxic elements, not even metals. Because why? Some of these elements, they are not even metal. They're called metalloids. I'm sure you heard of that word. If it's non-metal, if it's neither non-metal or metals, they are like in between, called metalloids. I'm sure you have heard that before. And then finally, radionuclides. So these are the elements that constantly emit strong strong radiomagnetic wave. So these are the non-stable, spontaneously emitting strong waves. So these are radionuclides. So these are the things that we want to cover. Bear in mind after this when I talking about the contamination, I'm going to refer to a lot of chemistry, either organic chemistry or inorganic chemistry. So I guess this one, I do not need to waste too much time. Where the soil pollution comes from, although majority of them you want to blame it to the pollution due to human activities, I would say the pollution happens due to human negligence. Negligence means kecuaian in bahasa Melayu. That means they knowingly knows the potential hazards due to their every action, but sometimes due to some other reasons, these pollutions still happen. And it's quite safe to say this reason mostly is due to financial reasons, financial benefits. So yeah, I won't say that humans are so evil that they purposely want to pollute the environment, but because when it comes to money, those are the things that comes into consideration. And you know why landfill is in a conversation here? Now, most of these toxic elements, they can be managed. They can be treated. They can be treated with so many chemicals so that they are safe and they are not hazardous to the environment. But somehow landfill comes into the spotlight because landfilling is said to be one of the cheapest way to handle pollutions. Um, is it safe? I won't say it is safe. There are some pros and cons in landfill, as you know previously from the other subjects like solid waste management. Landfill is the cheapest because all you need to do is take a hole, dump everything inside, and then close it. Of course, there are consequences, but it's the cheapest, right? So those are the things, yeah. And so the source of contamination can also come from various sources, either due to industrialization. So industrialization meaning that there are many factories that are located, and these factories somehow, some way, they will emit a small portion of those contaminants out. Again, it's not because they are willingly want to pollute the environment, but because it happens when you have industrialization. That's quite normal to have it. Okay, now by definition, I think I will skip because I think I've explained to you what is xenobiotic. But once again, if you don't know what does that mean, that means xeno means human, biotics means mates. Okay, so most of the soil pollution are due to human activities lah, and don't be like swayed by this picture. Although most of the pollution happens, as you can see right here, these pollution are due to mismanagement of solid waste. I won't say these are the, the true depiction of soil pollution that happens in the world currently. Now, for your information, when I say industrialization, that means the capitalists are coming in and to work and produce the goods through factory. Now, to blame on the soil pollution to the general public is probably not that accurate because for your information, the major pollutions that happens from the history, as you can see, majority of them are due to mismanagement by the capitalists. So I didn't say that all capitalists are to be blamed on this one, but due to the negligible ones, I have to say. All right. So the source of pollution, it can come from industry, it can also come from domestic, it can also come from household, it can come from anywhere. But let's use the current PKP. So currently, during PKP, if you still remember, apart from the movement control, the industry, they are all stopped altogether. So if you remember, before PKP, you heard a lot of issues, whether it's due to air pollution, it's due to water pollution. Before PKP, there are a lot of these issues. Okay, have you heard of that during PKP or after that, this time? Now, do you see what I mean? So that's why. By blaming the consumer, the general public, on the occurrence of environmental pollution is probably not that accurate. Just wait, okay? When the industry comes back, when all the factories come back to work, then you will hear again all this pollution coming back. So I think that is a very clear indication where are the source of this pollution. You can say quite safely it comes from the industry lah. Yeah. Okay, now the cause of this land pollution, as I said, it can come from all sorts of compounds because each of the xenobiotics that is produced by human, they in some way may be harmful if the concentration exceeded a certain threshold. So if you say that in the soil they have pesticide, you cannot say that it is very contaminated, that it is some point to cause a pollution. Because in the environment, there will be some small amount. In other words, we call it trace, okay? Trace amount of toxic elements. But it is not enough to cause any issue for your information. Yeah. So the land pollution of our concern that we should concern is when it reaches a concentration high enough that can affect human health or the environment. So in this case, most of the time when you have elevated level, when you have a concentration very high, high that can cause, high enough that can cause human concern, human health concern, usually they are due to an event of a major proportion, I would say. Now, in this case, the so-called event will be accidental spill, for example. Accidental spill, for information, is very different than illegal dumping, you know. So these are the gray area lah, yeah. Sometimes when you look at the environment, you will see the news reported as spillage. Now, spillage is a very broad word because it did not show whether that act is done deliberately or not. So I would say lah, if there is a major contamination happens in the environment previously lah, it's done deliberately and with some financial financial concerns lah due to it. Yeah. To save cost of treatment, people dump. I mean that happens a lot of times before lah, as you know. So I won't going to deliberate going to talk too much about the cause of the land pollution, and you should have known lah where does it comes from. Industry, there's so many. It's like endless, like if I want to show you the example. Yeah. Yeah. So the cause of pollution, littering, excessive use, and illegal waste dumping. So just now I've covered the third one, the illegal waste dumping, whereas the first and the second one, these may be very similar to illegal waste dumping, but number one and number two is done unintentionally or without the knowledge of causing it. Now, because human, when they dispose some garbage, for example, maybe your parents that maybe did not were not too educated and they dispose not according to the right procedure. Now that also may cause land pollution, but can you blame them? Well, obviously you cannot because they don't know. If they know, then that possibly can be avoided. It's the same with the second cause of pollution, excessive use of insecticide. Now, this is very common because when you look back at the people who use this herbicide, insecticide, and fungicide, most of the time these are the farming community. And by saying farming community, the traditional one are the ones that are possibly contributing to this one. Because when you talk about traditional ones, again, if they don't go to school and they don't know the proper dosage or proper use of insecticide, yeah, then that will also cause similar problem. You see, this is very common, like especially in India. India, there are a lot of farmers, poor farmers, so they only knew how to use when it comes to an effect that is effective to them. Then they use, even if if the concentration is too high for the right dosage. So again, the impact. So the impact can be so many. First of all, human health, and then environment. Now that if that happens, that we're going to have like an effect, a secondary effect to the other sectors. Of course, it could affect the tourism. Apart from tourism, most of the soil pollution, the impact that happens to human, the major concern will be the ability to produce food. Because if you look back, majority of the soil that is being used today are being used to produce food. Like if you want to have vegetables, fruits, or whatsoever, they are grown from soil. Very rarely, vegetables nowadays are produced uh, from aquaculture, hydroponics, for example. Yeah, I know there are a growing trend towards that due to the contamination of soil and also due to the lack of prime lands for agriculture. Singapore is doing it because Singapore island kan, so they don't have too much land to grow their vegetables. So they use hydroponic. Now Malaysia, it's not really that trend to go to hydroponics. In which Malaysia, if you want to know lah, the coming Malaysian plan, the next Malaysian plan, which we're going to begin this year for the next 5 years, the number one concern in that Malaysian plan is they're questioning whether or not Malaysia still have the ability to grow and sustain its own food production. See how serious that is. Now, majority of that concern is due to lack of manpower, but part of it is due to the lack of prime soil for agriculture. So I believe two two chapters before, when we learn about soil classification in Malaysia, you already know prime lands for agriculture in Malaysia actually is not that much, maybe around 10 to 20%. The rest of it either is too slopey or maybe the soil is not enough. So that is our concern. And if you add another factor, land pollution, then it further diminish the availability of lands for agriculture. So it's quite simple. If you take away the entire Kedah, do you think you can still eat Malaysian rice? I mean, that happens before. And that is why nowadays, if you want to know the major concern about land pollution, especially in Malaysia, is that we are currently net importer of food. So from that onwards, for the past 10 years, if not mistaken, for the past 10 years, Malaysia has been importing food. And the question is, for the next 5 years, can we use our soil to grow our own food and not importing from other countries? That is a big question to ask, isn't it? So today, it's quite timely that we learn why we should preserve our soil, so that when you have a good soil, then only you can grow your own food. So I have introduced to you what is soil pollution. So next, I'm going to something very technical. And it's quite safe to say after this, you're going to almost akin of a chemistry class. So I think right now you're still not asleep just yet. Can I say that? Okay, I assume that you're not, because I haven't touched about chemistry. Now only I'm beginning to touch chemistry. That is because I'm going to go into introducing to you what are the chemicals that are contaminating our soil. So I'm going to begin with the organic contaminants, then only I'm going to inorganic. But don't worry, I'm going to go really slowly. And if at some point that you cannot continue and you still at some point you are too saturated that you cannot absorb what I'm saying, then stop me. Switch on your mic and stop me. Okay. So with that, I'm going to start with telling you what is organic contaminants. So by saying organic, that means that compound, no matter how big or small, will always contain carbon. Okay, majority of the elements is carbon. Now, the elements as usually associated with carbon are usually hydrogen, and then in some point they may also contain other elements such as oxygen, nitrogen, sulfur, and so on. But here's the point, majority of the organic chemicals, they contain carbon and hydrogen. Now, what our concern? Now, of course, when we talk about organic compounds in the environment, you already know in the soil there are many organic compounds. Kan? Remember, the major indicators of a good soil is high organic matter. Is that organic compound? Yes, it is. Is the organic matter harmful to the soil? No, it is not. Because why? The existing organic matter that comes from dead leaves, the plants, maybe dead animal bodies, those are the ones that is not our concern. In fact, not only is not a concern, they contain nutrients that can be recycled by organisms in the soil. In other words, it's good. It's good for the soil. It's healthy for the soil. Now, what we are going to learn today after this is the organic contaminants or organic pollutants. Those are the ones that will hurt the organism in the soil. And they usually have a few characteristics that is very different than the soil organic matter. Okay. Number one, they are not biodegradable. Okay, so the one that are harming organic soil, soil organism, are those that are non-biodegradable. So the biodegradable ones are soil organic matter. The non-biodegradable usually they will go into to be considered as the pollutants or contaminants. And sometimes they also have another name. You can also call it as persistent organic pollutants. Now that is if that organic compound or that organic contaminants are of a small molecule, small, like they have like maybe at least two benzene ring, yeah, that is small. But sometimes these organic contaminants can be in bulk. Okay, like for example your plastic can, the polymeric is so long and so big, isn't it? So we won't call it as persistent organic pollutant. We just simply call it plastic, non-biodegradable plastic. So no matter how big is the size, if they are not biodegradable, they will cause trouble, yeah. So I think there are many more we can continue, but let us continue with this POP lah, persistent organic pollutant. Oh, okay. Just now I talked about biodegradable, okay? So I have referred to soil organic matter. And in that soil organic matter, they have some small components like phosphate and inorganic salts. These are the essential nutrient. Once they are degraded, soil organic matter, once they are degraded, they will release these ions or these components, and they will be assimilated by soil organism, including plants. Yeah, I think I will just skip this one lah, yeah, because they are like giving you example. What are the things that can be biodegradable? I think you know lah, since you already gone to secondary school. That includes carbohydrate, proteins, and so on. Anything that can be degraded by bacteria or yeast or fungus. And I think I'm going to skip the last part of here lah, because I was expecting the next few slides to be the non-biodegradable. Oh yeah, this one. So I'm sure you know what is biodegradable things, and the non-biodegradable ones. And I'm sure now you can see a lot of strange words, strange keywords. And I'm going to spend a little bit of time and explain to you one by one. Okay. So following with the non-biodegradable organic pollutants. In other words, we also call it POP. POP, who stands for persistent organic pollutant. POP. You see, POP has emerged in the 1980s, and then very recently there was a treaty being signed by developed countries as well as the whole world, limiting the use of POP. So you probably don't know what is POP, isn't it? So the name itself already telling you what they are. Persistent organic pollutant, meaning that these organic pollutants simply do not go away easily. So when they are released into the environment, they stay in the environment as it is without too much of degradation. So by saying that, that means they will degrade, but extremely slow. So no matter what is thrown to them, like it microbes, like it's sunlight, or maybe temperature, they can stay for a very long time. Now, what is the issue here? Now, the issue here is that coincidentally, most of these POP, they are also toxic. So in terms of toxicity, nobody wants it, like it can kill a lot of things. And that is the issue. Because why? In that treaty that I say to you that is signed by a lot of countries, in that list, in the list of POP, majority of those POP are pesticide. Yeah, pesticide that kills, right? Yeah, and that is the issue. Like imagine that when you when you release a poison in the environment, and it seems like these poisons simply don't go away. So chances are it may kill a lot of people. It's just like COVID. Like COVID outside, yeah. And then the problem is when COVID is outside, people cannot go outside because when it comes in contact with COVID, they kill them. It's the same with POP. Yeah. And that is the issue. Now, the examples of the POP could be components of crude oil, crude petroleum, PAH. PAH stands for polyaromatic, polys, it's down here, PAH, polynuclear aromatic hydrocarbon or polycyclic. There's another name, polycyclic aromatic hydrocarbon. So what does that mean? That means this organic compound consists of a lot of hexagon, a lot of benzene ring. When you have a lot of benzene ring, more than three for information, and you fuse them together, yeah, that's it. It is called a pH. It doesn't matter, like as long as you have three benzene ring or above, and you fuse them together, you can call it a pH already. And then furthermore, plastic product from petroleum as well, inorganic chemicals. So these inorganic chemicals, some of them, they are not biodegradable. Like for example, there are inorganic chemicals that I think I will switch on the next slide. Cannot recall what are the examples. But I think most of the POPs, they are pesticide or they are like polycyclic aromatic hydrocarbon that have a lot of hydrocarbon and with a lot of benzene ring. Yeah. So usually these are the ones that are difficult to be degraded by bacteria. Now there are a few more acronyms that you can see here. PCB. PCB stands for uh, I think I will need to look at the next slide because I think the next few slides there are introduction of PCB. If not, then we can use Google and search for it. DDT, I'm sure you know, it's one kind of the pesticide that is used previously to kill insects, and there's a very elaborate stories on the after effects of DDT to the environment. So these are the examples of what we call organochlorine organic compounds. Organochlorine means you have majority of the carbon with a few containing halogens like chlorine, fluorine, or even bromine. And it is said that the inclusion of this halogen further magnifies its toxicity. So I couldn't recall what is the full name of PCB and DDT. Hopefully after this, in the next few slides, you can see it. Okay, now the identity or the characteristic of organic pollutants. Now we learn about the behavior. Okay, so now once you have organic contaminants in the environment, how do they behave when they're exposed to sunlight, when they comes in contact with rainwater, high temperature, low temperature, when they comes in contact with soil? What happened? Yeah, that is what we're going to talk about. Okay, now it all depends on what kind of organic pollutants are you talking about. Like I told you, some organic pollutants can be very big, some may be very small. Now, because of that, their behavior in the environment will be very, very different. So it comes back to chemistry. If it's very big, that means it is not easily evaporated, something like that. If it's very small, maybe it can be more soluble in water. Example. So we're going to learn one by one according to xenobiotics, kind of organic contaminants, and also behavior of organic chemicals in the soil. So the last one is more of the fate of organic contaminants in the soil by referring to a few examples. Yeah. Okay, xenobiotics, I believe I've talked about it, so I will skip. And we're going to go through examples of the so-called organic contaminants. It could be industrial organics. Now, this one industry, I would say they are mostly involved in the electronic manufacturing as well as mostly manufacturing. Either you manufacture electronics or plastic, but most of these industrial organics comes from the plastic manufacturing. Yeah, either they're used as solvent or maybe some foaming agent. Most of them they're solvent. Yeah. And then, of course, pesticide, they're used in the farms. Yeah. So industrial organics, it could be benzene. Now, benzene, I think we don't need to go too far away. You just look at your uh, petrol, the petrol that you put in your motorbikes and also your car. Do you know that inside your petrol, there are already 5% of benzene? If you don't know, here you go. Benzene, what can they do to you? They can do a lot of nasty things. Now, first of all, they get into your body, and then they will stick themselves to your fatty tissue. And then after that, they stay there. They stay there until you get enough benzene, and then from there, they will cause a lot of damage. Damage to your cell until at one point you may cause cancer. Yeah, that is what benzene can do. Whereas the other one, polyaromatic hydrocarbon, also is similar. The only difference is benzene, how many rings? Just one ring. Polyaromatic hydrocarbon, how many rings? Okay, listen carefully. In order to be counted as PAH, you must have at least 3 benzene rings or above. Less than that, it does not count as PAH. Yeah. So remember that. Yeah. Sometimes in my previous test question, I asked students, okay, give me a chemical structure of a PAH, and then they glabala, they start drawing one benzene ring and then attached with a lot of halogens. No, that is not correct. Remember, you put at least 3 benzene ring, no matter how you arrange it, that will still be the answer lah. Yeah. And then solvent used in manufacturing such as trichloroethylene. Now this one, I'm not sure where does it use it, but a lot of solvent has been used in the manufacturing. Like for example, if you have heard like in the production of electronics, they have motherboard, isn't it? Now, most of the time, this motherboard, they're handled by humans. They have fingerprint. At some point, they have to make sure that there are no oils, no human oil, no contaminants on the motherboard. So how do they remove those fingerprint? They just spray with acetone, either acetone or CFC. Previously, they used CFC. So they spray and then CFC evaporate, acetone evaporate. That's it. Very clean. They don't use water, yeah, because why? You spray water in your electronics, then they burn lah. They usually use solvent, not water, not water-based solvent. And then try nitrotoluene, TNT, explosive lah, I would say. TNT is explosive. Now this is majority used in the quarrying industry. Whether or not this is toxic, I believe it is toxic because TNT actually, you can imagine that it is a benzene ring and then there's nitrate, 3 nitrate attached to that benzene ring alternately. So as far as I know, anything that contains benzene ring poses a risk of cancer. So it doesn't have to be benzene, you know. TNT also have a benzene ring. It is a derivative, looks similar like benzene. So there you go. You will have some risk of cancer. Okay, now coming back to what I've told you just now, PCB. I could not recall what is the name of PCB. So here it is. PCB is polychlorinated biphenyl. So that is what PCB stands for. It means this compound will have 2 benzene rings joined together through a bridge, and they have halogens around those benzene rings. I hope after this you have image of this one. That's quite hard for me to explain to you and describe how does it looks like. Yeah, there you go. So PCB, as you can see right there, 2 benzene ring bridged by a covalent bond is a kind of like a spectacle where around this benzene ring you may have multiple chlorine, not just one. It could be more than that depending on what kind of PCB. PCB, for information, is not one compound. PCB is a group. It's a group that assembles whatever the organic components that look like this, 2 benzene ring bridged together, and then doesn't matter like how many halogens, as long as the halogens that is surrounding it. So this is PCB. And as you can see right there, TCE, PAH, TNT. So TNT is like this one, explosive, and PCP. Now, I myself is a chemist, and I'm not so sure really what are the full use of these organic chemicals. So here's the thing. I'm sure some of you might be worried, oh, do I need to memorize all this chemical structure? Okay, here's the good news for you. You don't need to. You do not need to, but depending on what I explained just now, I'm sure if I ask you to draw a chemical structure of one compound, I'm sure you know which one that comes out like.